So there's a question on FreeCodeCamp about Heap's algorithm, specifically the Wikipedia article on Heap's algorithm. And the question is, given the function to perform the algorithm, how exactly does it work through the steps to take you from ABCD to BACD to CABD and all the way through? So Google search shows that this isn't the first time that this exact question has been asked, and there doesn't seem to be an answer out there for it. So I'm going to do my best to walk through each step in the Wikipedia algorithm to show you how it works through the heaps algorithm. So we start off, the Wikipedia is just gives pseudocode, so it's not real running code. It's just basically a framework. It's going to show you how to walk through the steps if you were to generate your own function for this. But it's a function, and the function takes two parameters, two arguments. And those two arguments are an array and an integer. And the integer represents the number of elements in the array. So we're going to use an array of A, B, C, D. And because there's 4 elements, our n is going to equal to 4. So we're going to pass those arguments into the function, and we start off if n equals 1, then output A. N doesn't equal 1, it equals 4. So we fail that test, we move to the else. In the else statement, there's a for loop. The for loop is standard. It starts at 0, it has to pass a test, and if it does some things, and then it increments by 1 and keeps doing that until it doesn't pass the test. So in this case, I is 0, I is less than n minus 1, 4 minus 1, 3, so 1 is less than 3, so we can go into the for loop. This is where it gets tricky. As soon as you enter the for loop, there's a recursive call to the generate function, the same function. It's calling itself. So we can't really do anything else. We can't pay attention to anything else that's below this. We have to address this recursion. So it's going to open up another sort of instance of the function being run, but this time it's passing in the array, which is currently A, B, C, D, and it's passing in n equals 3 because it was n minus 1, n was 4, 4 minus 1 is 3, so now over here n is equal to 3. So if n is equal to 1, it's not, it's 3, so we move into the else, we move into the for, still passes, and we hit the recursion, which opens up another instance. 3 minus 1 is 2, so now step 3 is n equals 2, and it does not equal 1, so we move to the else, we move to the for, and we hit the recursion statement. And that takes us here. 2 minus 1 is 1, if n equals 1, and it does. So in this case, we're going to output the array, and our array is currently A, B, C, D, and that's what we're going to output. If we were outputting it to the screen, that's what would print right now, A, B, C, D. So now we have to step back to where we left off. So we did this part. Now we have to go into the if. If n is even, in this case it is. If n is even, then swap A at I. I is currently 0. So we're going to swap A at 0 and n minus 1. 2 minus 1 is 1. So we're going to swap elements 0 and 1 from our current array, which is A, B, C, D. Elements 0 and 1 is A and B. We're going to swap those. So now our new array is B, A, C, D. So now we increment I now becomes 1. Is 1 less than 1? No, it's not. So we break out of the for loop and hit another instance of a recursion. So we're going to bring that down here just to make it a little more clear. So we'll call that step 5. N is 1. If n is 1, and it is, then output A. So we're going to output our current version of our array, which is BACD. So now we need to step back to where we left off, which is here. So we did this recursive call. Now we're in the if statement. And if n is even, it's not, it's 3. So we're going to swap A at 0 and A at 2. So 0 and 2. Our current array is B, A, C, D. We're going to swap elements 0 and 2. We're going to swap B and C, and that leaves our new array as C, A, B, D. Now we have to increment I equals 1. So we're going to go into the loop. I is 1, n is 2, 1 is less than 2, so we're back into the for loop, and we hit the recursive call. Which brings us here, which brings us here, which brings us here. And if n is equal 1, and it does, and we're going to output our current array, which is CABD. So now we need to step back to where we left off, which was right here. If n is even, and it is, n is equal to 2, we're going to swap A at 0 and A at 1. So we're going to swap 0 and 1 in our current array of CABD, 0 and 1. So we're swapping C and A, and we're left with ACBD as the current version of our array. So now we increment, I is now 1. 1 is not less than 1, so we break out of the for loop, and we hit the next recursive call, which brings us here, which brings us here, and we get to output the current version of our array, which is ACBD. ACBD is now done. Now we're going to step back to where we left off, which was here. And we need to swap A at, well, currently at 1. And n minus 1 is 2. So we need to swap, oops, sorry, this is odd. So we need to swap 0 and 2, just like last time. Sorry, that's confusing. So 0 and 2, and our current array is ACBD, so we need to swap 0 and 2. We're swapping A and B, which is going to give us our new array of B, C, A, D. And now we increment this to 2. So now is 2 less than 2? It's not, so we break out of the for loop, and we hit this recursive call, which brings us here, which brings us here, which brings us here, and n equals 1. So we're going to output our current array, which is BACD. And step back. Our I is currently 0. We need to pick up here. If n is even, it is even. We need to be at 0 and 1. So we're going to swap elements 0 and 1 from our new array, which is BCAD. 0 and 1, B and C, we're swapping those. And we have our new array of C, B, A, D. Now we need to increment this. 1 is not less than 1, so we break out of the for loop. We hit the recursive call to n equals 1. N does equal 1, so we output CBAD, which is our current array value. So now we need to step back. To where we left off, which is way back to here. This is where we left off. Our current array value is this one, CBAD. If n is even, it is, at n equals 4. Swap A at I, which is currently 0, and A at n minus 1, which is 3. So we're going to take our current CBAD and swap elements 0 and 3, 0 and 3, which is C and D. And you can see how those are, even though it's cut off, that those are the ones that are being swapped, and that's going to leave us with an array of D, B, A, C. And if we check the longer version after CBAD comes DBAC. So we've worked all the way through the first section. You can see that how that works is the last element, D, doesn't get touched at all. So we run through ABC and we do every possible permutation of those three until we run out of possible permutations. And then we swap out the last element, D, and then you'll see that C stays there and C doesn't get touched throughout the whole time. And it just swaps those three. And then B doesn't get touched the whole time. It just swaps the first three. And then A doesn't get touched the whole time. It just swaps those. So you can see how we've run through all of the steps of the algorithm successfully up until the first, fourth item swap. So if you want to keep carrying through that, you're more than welcome to. But I hope that I've been able to explain far enough in how this multiple recursion algorithm takes us from these steps through these steps.